Hi, this is Dave Johnson with another edition of Math Off Topics. Today I want to talk about related rates problems, and I want to share with you my personal recipe for this. There's nothing special about my recipe. I hope, and I imagine all teachers have their own way of doing these problems, and I hope the students uh, eventually come up with their own way of solving these problems. Let's take a look at the problem that I have in mind for today. So I'll read the problem. Given an isosceles right triangle, if the length of the hypotenuse decreases at the rate of 4 meters per second, how fast are the legs changing when the length of each leg is 5 meters? Well, so always read a word problem 2 or 3 times, get a feel for it, even before you try writing equations, before you do any real math on it. Make sure you understand what the problem is saying. And it's often a very good idea to draw a picture. So I'm going to draw a picture of an isosceles right triangle. And so it's a right triangle. Isosceles means that the two legs are the same length. And I'm going to label those legs A. And then I'm also going to label the hypotenuse L. And so part of the recipe, first of all, identify the dependent variables. So dependent variables. What do I mean by a dependent variable? Well, you could say that A depends on L, but uh, that's not what we really mean here. Both the L and the A depend on time, and so time is the independent variable. The L and the A's are dependent variables. So I'll say L and A. And so we're given an isosceles right triangle, but we're also given the fact that the length of the hypotenuse decreases at the rate of 4 meters per second. So I can write dl dt is equal to -4. And what we're asked to find is how fast are the legs changing. So when the length of the legs, when each leg is 5 meters long. So we're specifically being asked for dA dt, and that's question mark, when A is equal to 5. Okay, so notice that the dependent variables are precisely the variables that we're differentiating in our rates. So L is one of the dependent variables, A is another dependent variable. And if we could have a relationship between those dependent variables, so that's the next step, is find a relationship between those dependent variables, then we can eventually get the relationship between the rates of those dependent variables. So what is the relationship between the dependent variables? Well, in some cases, you might have angles and you might be able to do trigonometry, but in this case, we have a right triangle, so we can just use the Pythagorean theorem. So we know that a squared plus a squared is equal to L squared, and so 2a squared is equal to L squared. So that is the relationship between the dependent variables. So we found the dependent variables, we found a relationship between the dependent variables, and now we're going to differentiate that relationship. In other words, we're going to take the L squared equals 2a squared, and we're going to differentiate both sides with respect to t. So d by dt of L squared is equal to d by dt of the 2a squared. On the left side, we get 2L dl dt. Don't forget the chain rule. On the right side, we get 4a dA dt. Now, what are we solving for? Well, we want to know what is dA dt. So let's go ahead and solve this equation for dA dt. So I'm going to write dA dt on the left side equals, divide both sides by 4a, so you get 2L over 4a. times dl dt. And we can simplify that. So dA dt is equal to L over 2A times dl dt. Now we know the dl dt, we're given that, that's -4. We also know that at this point, A is 5. Now, you cannot plug A in before you do the derivatives because that would just make it wrong. You'd end up with zeros where you don't want them because at that point, A would be a constant. So, but at this point, we've done the derivative, so we can plug in A, but we're not quite there yet because we need to figure out what L is. So let's go ahead and solve this equation for L. So L, take the square root of both sides, we get the square root of 2 times square root of A squared is A. And if A is 5, then we get the square root of 2 times 5, or 5 the square root of 2. So now we can plug in. So L is 5 square root of 2 divided by 2 times A, but A is 5. And then dl dt is -4. The 5's cancel. We can write this square root of 2 over 2 as 1 over the square root of 2. And then times -4. So -4 divided by the square root of 2. And we could simplify that further. So -4 times the square root of 2 upstairs divided by 2 downstairs, because the square root of 2 times square root of 2 is 2. So we get our final answer is dA dt is equal to, the 4 over 2 is 2, so we get -2 square root of 2. Now at this point I would like to do a sanity check just to make sure that we're not completely off base here. So because the hypotenuse is decreasing in length at a certain rate, then we would expect just from geometry alone that the A's would decrease in length, and that's why we get a negative rate for the dA dt. So I hope this has been helpful. And if so, please like and subscribe, and I will see you in the next video.